Hi friends, so this is then setup of an experiment of a Maxwell bridge. Inside figure arm 1 with the R1, second arm with the R2 in parallel with the decayed box of capacitor, variable capacitor, arm 3 with the R4, arm 4 with the R3 in series with the inductor. There is a two component more multimeter at place of null detector and the AFO, that is the audio frequency oscillator. We choose 1 kilohertz. So if we start the experiment, how to connect it, then these are the setup: R1, R2 decayed box of capacitor, R4, R3 in series with the inductor, multimeter and the AFO. Let's start connection. Inside figure I am showing the line diagram, connections of R1 to R2, and that is one terminal of R1 to first terminal of R2. R2 will go to the second terminal of R2 will go to the first terminal of R4, and same way R4 second terminal. You can also see the line diagram in the inside figure. R2 R4 will go to the first terminal of R3. R3 and inductor are in series, so second terminal of R3 will go to inductor. R3 second terminal will go to first terminal of inductor, and inductor will go back to the point from where we begin, that is R1. So this is a loop circuit is over. Let's start connections of in capacitor parallel with the R2. So we unscrew the R2 and tie up over there. So variable capacitor is in parallel with the R2. After this we will connect the AFO. Let's take the one terminal of AFO is in common terminal of R1 and inductor. So I am plugging into the inductor in a banana pea, and then the second terminal, you can see the line diagram. The second terminal of AFO will branch to the common of capacitor and the R. So I will be unscrew the R and tying up here. It should be common with the R4. So R2 and R4 common terminal I will be connecting the AFO. Now the multimeter will set on the AC voltmeter 2 millivolt range. There is a two wire, one common and 1 volt. Will be connecting one of them is to the common of R1 and R2. So common of R1 and R2 in connection with the capacitor. So I will be unscrewing that. Rather I have banana, so I am plugging into the banana to the capacitance terminal, which is connecting commonly with the R1. The second one will go in between the R3 and R4 common. So I will be unscrewing the R3 terminal and connect it here. So this is the end of circuit, and now I should move towards how to take a reading. The balance breach condition will indicate the minimum reading of a multimeter. R1, then heavy resistor value will be equivalent of a R2, having its resistance value will be equivalent to the R4, whereas R3 and inductor are in series, so their summed value, their summation of their inductive value will be equivalent of the rest 3 branch, that is R1, R2 and R4. So that way we can able to balance the breach DC level. Now AC component will be compensating to each other, inductive to capacitive. If I turning on, I have 1597 reading. If turning on the level 1 of a capacitance, it reduced to 159 something to 153, and if I increase to 2, it's again shoot up. So the previous reading is better, so I'm keeping on that. So let's check the next button, but I am not finding too much variations. This indicates me that I have to go one step previous to that, so rather than 0.2 I will moving to 0.1, so I can check it up the more variations of the level 2 or the button 2. So 0.471547, if I will increase a step more and check whether it is decreasing, that means I am moving towards the more balanced condition or not. So yes, 43241. You have to give a little bit time to get settled down. Then 1541, not too much variations. Let's go one step more. Oops, it's a standby mode. So let's turning on, turning off, turning on, and it's again active. So it's 1540 if I will move step ahead, it's 1538 and well stable. So I think it's a very much better balance condition. If I will move it to the 8, it's still stable. Let me check it on the one step more, and then I can sum up this values. One five three nine, so this is a reading of my first values of inductance. 0.1 microfarad having step 1, 0.01 microfarad having step 9, both are in parallel, so it's a 0.19 microfarad, and that way I will change the different value of each branch resistive value and find it out the corresponding balance condition. Okay, thank you so much.